everyone, my name is Joel Florian Colasso. I'll be going through the design and requirements document for the Morse code project, and afterwards I'll be going over the demo. So the project consists of me implementing a Morse code on a microcontroller based board. So I selected to use the Lego Mega 2560. On that board I'll be writing an application which will essentially have the user type an input string, and the application will convert it into Morse code and then eventually display the Morse code on an LED. So if we look at the hardware requirements, we're going to need the Lego Mega 2560 board, which is where we'll be hosting the microcontroller and where we will be sending the program serially to the board. We'll need a USB-A to USB-B cable, which will allow us to download the program on the board. We'll need a blue LED, and we'll need a host computer, which is where I will be writing the code. Since the Mega board already has a resistor between pins 13 and ground, we don't need an external resistor. So what I did is I essentially placed two jumpers from those pins onto the LED, and that will essentially be enough for it to drive the LED on or off. Software requirements. So project was developed using the Arduino IDE, from which we download the program via USB. And essentially we had to comply with the project requirements, in which the user will be entering a text. The application will convert it into Morse code. The Morse code will then be displayed on an LED as pulses, and then the application will employ a round-robin design where it will continuously loop until the user enters a carriage return character. So how the program will flow, it will essentially be the user will enter an input string, press enter. The program will take that string, convert each one of the characters into its equivalent Morse code, and then the Morse code will then be displayed on the terminal and as well on the LED that we previously talked about. Okay, so now we'll go over a quick demonstration. Okay, so first let's go over the code, and then we'll go over the microcontroller in action. So first I defined some constants. So the LED pin will be pin 13. Here I defined the time that each dot and dash will take. So each dot will be 1 second, each dash will be 3 seconds. Time between the Morse characters will be 1 second. Space between words will be 7 seconds, and the time between letters will be 1 second. So initially I set up the serial interface. So you initialize it here. You initialize the pin as an output, which is what will be driving our LED. I then define the flash LED function. This is the function in charge of turning on and off the LED for their corresponding time. If it's a dot, it'll be as we mentioned, 1 second. If it's a dash, it's 3 seconds, and then we'll give the appropriate delays. Okay, this is what I call the convert to Morse function. This is where we take in the original input string and we convert it into Morse characters. So this is, I then convert it into lowercase and then go character by character, converting it into its equivalent Morse code. And then down here, loop is where we have the main loop. We will be defining the input string, a variable. Whenever we see bytes in serial interface, we will read that and assign it to the input string. And then if we see the carriage return character at some point, that will signal us to exit the loop. If not, it'll go ahead and start with the main program, which is where it converts the input string into its equivalent Morse code. Okay, so here we have the Iligo 2560 board. As you can see, it's already connected to my computer, and it's already have the LED connected to pin 13 and ground. So we'll go ahead and download the program to it. Okay, so the program is already downloaded. Now let's go over an example. So we'll go over the word hello as an input. So just as a reminder, this is the Morse code conversion to the word hello. And as I mentioned, each one of the dots will be 1 second, each one of the dashes will be 3 seconds, and there will be a 1 second delay between each one of the letters. So let's go ahead and write the word hello and press enter. So that's the letter H, that's the letter E, that's the letter L, that is the letter L, and finally we have the letter O. Okay. Now, if we want to enter more inputs, we can. So go to the terminal, we enter the letter K, enter. You'll see the Arduino also respond to the letter K. And if we send the carriage return as an input, that'll be our signal to exit the main loop. Okay, so if we press enter, the Raspberry Pi, the Arduino will exit the loop, and then if we enter any other character, it will no longer respond to the input. Okay, so that concludes the demonstration. Thank you for your time.